This is a video on integration that involves the arcsecant of x. The question is to integrate dx divided by x times the square root of 2x squared minus 1. This looks very similar to an arcsecant integral, except that this pesky 2 is here. So remember that the integral of dx over x times the square root of x squared, notice no 2, minus 1, is the arcsecant of x plus c. So we want to deal with this 2x squared. 2 is not a perfect square, but what we can do is we can write 2x squared is the same as square root of 2 times x quantity squared. And we do that and rewrite our integral with the square root of 2 times x quantity squared inside the root. That will indicate what our u is. We let u equal root 2x. And then, of course, the derivative is just the square root of 2. And now let's solve for both x and for dx. We get dx is equal to 1 over root 2 to u, and x is equal to u over root 2. Now we can substitute everything in. The dx became du over root 2, the x became u over root 2, and the root 2x became u. And this is kind of nice because both the numerator and the denominator have an over root 2, so those root 2's will cancel. And what I get is the integral of du divided by u times the square root of u squared minus 1. And that is an arcsecant integral with u, so I get the arcsecant of u plus a constant. My last step is just to resubstitute. U is the square root of 2x. So my final answer is the arcsecant of the square root of 2x plus a constant. And I'm done with the problem.